in Venice, but I can't really get it to work without making it funny. But got into Neo and graph, and got really deep into graph theory, and felt that that could help my passion, which is customer and human experience. So I think graphs can help me do that. So.
Nice.
Cool.
Syed, do you want to?
Sure. Yeah. I'm Syed. I'm working for Newly, and we've been working with graphs for the past maybe 5 years, 6 years. And we are using it mainly in the context of identity and access management, mainly. Yep.
Elena.
Yeah, hi, my name is Elena. I'm situated in Germany and I work in the automotive industry. I've started working with graphs a year ago.
Oleg, you can say skip, by the way, if you don't want to introduce yourself, just for the record. Okay, Oleg, if you might be on mute, I don't know if you mean that or not, but we could say, Michael, are you here?
Yes. Can you hear me?
Yes, we can't see you.
Yeah, my setup's a little funky right now. I'm in the middle of moving. So, my name is Michael McKenzie. I'm with Washington, D.C. I work right now with Caliber as a programmer. And I got to Neo4j almost 4 years ago with a bunch of personal passion projects. And my background actually is civil engineering. So that's kind of where I started and then switched over full time to use Neo4j.
Nice. And Koji? You're on mute. I don't know if you know.
Hi.
There we go. It's 4 a.m. for Koji, so he is for being here.
Yeah. My name is Koji Anola from Japan. I started Neo4j user group in Japan at 2013. I love Cypher and Neo4j. Yeah.
Awesome.
Great.
So Matt, I'll let you guys take it from here. I don't know if Oleg, I guess maybe Oleg's on a skip me mentality now, so we could just continue. So if you guys want to take it from here, and we could do something kind of interactive and off the record. So if anybody has questions, I mean, you guys see it's a smaller group, so like feel free to chime in, ask questions, you know, like this is.
Yeah, sure. Please interrupt me at any point if you have a question.
Please interrupt.
So I'm going to share my screen. Okay, so I'm going to share with everyone about stored procedures in Neo4j. This is talk is sort of it's a bit of a story. It's loosely based sort of on how I learned to use use stored procedures in Neo4j, based on experiences early in my career when Ravi was my mentor, and we were working together on this challenge. And so anyway, I'll show you some slides. Then we'll have a look at some code, see how these things work.
Matt, let me just interrupt you for a second. The background.
That was quick.
Sorry. So the background for this call was actually Karen has asked in the field how we use it and what kind of things we try to do and what kind of why we make certain decisions. That's where this talk came into picture. And another thing is because Cypher, quite a few people, there have been this thing, but about store procedures, why and when we use store procedures. So we wanted to have a little bit of more involved things. So the example we are showing, myself and Matt, we built a sort of demo or proof of concept, which is we can show from where we started and where we ended up. And he will show a demo of the application also to see, to appreciate why and how when and why we use these things. So that's the background of it. So whenever you guys have any questions, anything that does that confuses you or that doesn't make sense, please raise the question. Sorry.
Great.
Thank you.
Okay, so I'll start off with the challenge. So one of the cool things that you can do with graph databases is event-based modeling. And in event-based modeling, what we're basically doing is we're looking at the activities of individuals as a sequence of connected events. And these connected events form something that we can call a story or a journey. Once we aggregate the individual journeys, we can do a lot of interesting things. We can start to detect patterns of behavior among groups of individuals. We can start to spot outliers who are not following that pattern of behavior. We can start to identify individuals who are similar based on having similar sequences of events or behaviors. Using these similar individuals, we can form communities. And we can use these communities to predict future behavior based on what other members of the community have done in the past. Event-based modeling can be visualized effectively using something called a Sankey diagram. A Sankey diagram shows the flow of events across a population, and the thickness of the band representing the event is proportional to the frequency of that event. So this is a good way to visualize actions across a large group of individuals and to highlight common patterns. This is just a sample diagram that I pulled from the web. It shows the example of a person who applied to jobs. So the job search process, they started with 32 possible jobs. They got replies from about half of them. That led to interviews with some of them, and some of them had tasks. And eventually they got 2 offers and accepted 1. So continuing with the challenge, one of the areas in which event-based modeling is quite useful is in the healthcare domain. In the healthcare domain, we look at the events that are that make up the journey include things like you're diagnosed with a condition or a disease, you're prescribed a medication, it's discovered that you have an allergy to something, some sort of medical procedure is performed, these kinds of things. So by aggregating these journeys, this allows us to detect patterns in medical treatment, to pick up trends in disease, and potentially to predict patient outcomes based on the journeys and experiences of similar patients. So the challenge, we had a large data set of patient events, 1 million patients, around 100 million total events. That includes like condition diagnoses, procedures, medications of that sort. So the question is, we want to generate Sankey diagram that can enable us to answer questions such as, what are the most common sequences of procedures performed within 30 days after you've been diagnosed with a condition? And by looking at patient demographics, we can filter these to see if there are any changes in these patterns based on things like age, gender, or race. So the challenge is that we need to be able to return this information for thousands of patients, and we need to do it quickly because we want to generate these diagrams on demand. So we're looking for around 2 to 3 seconds of response time. So given that challenge, this is the model of the graph that we had. The most important features for this are on the left. You see there is a patient node. Patients have encounters. These are the events. Encounters are tied to each other for the patient by the next relationship. And then encounters can have particular events that occur during that encounter. These, the ones that we are interested in for this is has conditions, when a condition was diagnosed, and has procedure, meaning that a procedure was performed. So given this model, I decided to try to take a crack at answering that question using Cypher. So my query looked roughly like this. I'm not trying to do any filtering yet, but I match patients. I'm not trying to filter on patient demographic yet, but I match any patient that has an encounter in which that has a condition with the specified code. Then from that encounter, I traverse the next relationship. When I use the next, I use the star modifier. It means like unbounded, however many there are. Look at all of them. And then we look at those events that have procedures associated with them. We're only interested in the first 30 days, so we check the encounter, the date, and check that it's within 30 days. We collect all of the procedures using the description property, which is just the name of it. That gets collected into a list called, we call it items. It's actually like the patient journey itself. Furthermore, we aggregate them, and then so that we have for each path the number of patients who followed that path. And then we filter to only return paths that had 10 or more patients. So that looks like it should work. And it does yield the correct answers, but unfortunately it's very slow. We found that looking at the 1 million patient data set for conditions that were not very common, they could even still take minutes to return. For conditions very popular, we found that often it never returned at all. We saw high resource consumption on the server, just generally pretty bad news. So if you actually look at the query profile, you can sort of see what the fundamental problem is. In the top box here, this is where it is expanding the next relationship. So it's a variable length expand all. What it does is it expands out all of the next relationship, and then it performs a filter based on the date. So it pulls all the next and then throws a lot of them away if they're out of the date range. So this is very inefficient because we know that the next relationship is in date order. So the next is always going to be the date at a later date. So when we look at the next relationships, we don't need to expand all of them. We just need to look at them one at a time and check if it's within our date range. We're not really able to do that using Cypher. So at this point, I was kind of throwing up my hands and saying, well, what do I do next? So at that point, I turned to Ravi and asked for advice. And that I started to learn about Java APIs. So Cypher is not the only way that you can interact with graph data. There's a variety of Java plugins that can be used. You can write custom procedures and functions to extend Cypher. Other kinds of plugins include for authentication, you can add additional REST endpoints called unmanaged extensions. I'm not really going to get into those particular kinds, but the first kind, custom procedures, yes. There are 3 different APIs that you can use in these. The recommended one is to use whenever possible. It's the main Java API. So here, you're dealing with nodes, relationships, and properties. Those are the sorts of Java objects that you have. We'll see an example of this in code later. Other APIs that exist include the traversal API. This allows you to describe paths through the graph in a declarative manner. And then finally, there is something called the internal kernel API, which is a little bit secret, but you can get at it. If you need, for some reason, super duper low level access, you can work with cursors, tokens, and read objects. It's advisable not to use this library because it's subject to change without notice between minor versions of the product. I just wanted to mention that it does exist. So how does one build a stored procedure? Well, you write just regular Java classes, and you use annotations like procedure, description, and name to identify the procedures and their parameters to Neo4j. One rule is that your input and outputs to the procedure have to be Java equivalent of Cypher types. So you can't use just any Java class. Classes that you can use include scalars like long, float, string, various data types and durations, graph primitives like nodes, relationships, and paths. You can also use lists and maps of other Cypher equivalent types. You have access to a handful of classes with your stored procedure from the context, and these use a context annotation. The most important one of these is what's known as the graph database service. This provides a handle to the graph so that you can write and read to it. You also have access to Neo4j's internal logging and something known as the termination guard, which makes sure that your query is still active. So once you've written your procedure, the protocol for packaging is to compile it into what's known as a shaded, sometimes called a fat jar. This is a Java jar that has all of the dependencies packaged in with it. So these run within Neo4j. That, having it in a fat jar provides a security sandbox for your code. If you have a plugin that writes to the graph, then there's a further security step, which is that it requires to be explicitly enabled in the neo4j.conf file. So once you have that jar, you just copy it into the plugins folder on your server and restart the database. So some cool things you can do with these. You can call your custom procedure from Cypher. The syntax to do that is you'll recognize from calling internal procedures like the DBM called dbms dot whatever, from like the APOC calls. It's the same sort of thing. Call your procedure with parameters and then yield and return. You can use any JVM language. Other than the restriction about inputs and outputs, there's really no limitation on what can be done. You can use remote debugging, just like with any JVM code. So you can do step-through debugging on your procedure, which is pretty cool. And they're easy to test. If you've used the Neo4j test harness, it's easy to get it to recognize your custom procedure. And you don't have to do the compilation and the jar, all that stuff. You can just tell it the class of your procedure, and then you'll have access to an in-memory server that knows about your custom procedure. So when is it good to use a stored procedure, and when is it best not to? Well, if you need to have access to something that's not available in Cypher because it's a third-party system or library, that's a good case. If you need some other sort of functionality, like some specific procedural logic that can't be expressed in Cypher, that sounds a lot like our use case. When not to use? Well, generally when Cypher is good enough, it's fast enough, it's generally preferable to use. Because it's external and people know Cypher, it's easier to share, all things like reasons like that. So having learned this information, we figured that stored procedure would be a good thing to try to solve this particular problem. So I took a crack at it, and this is the description of how the stored procedure will work. So we first find all the start points. So what this means is that we find the encounter in which the patient was diagnosed with that condition. So first we need to know are the demographic filters apply to the patient. And then we find encounters of interest for these patients, encounters where the condition was diagnosed. Now that we have these start points, we can, which are encounters, we can traverse the next relationship along the encounters until we're either outside of the date range or the patient has no more encounters. As we're doing this, we collect the medical procedures that were performed during these, and this forms a path, which is the patient journey. Finally, we have these collected paths in a map that we keep count of the number of occurrences. So we can see how common a particular patient journey is. Having written this, we tried it, and it was quite successful. I was able to dredge up the Slack message that we exchanged months ago. It was super fast, got instantaneous results for uncommon conditions, and even the most common ones took only a couple seconds. So that proved to be fast enough to drive our interactive diagram. I have links to some further resources, but so I wanted to show just the results of this procedure. We have the Sankey diagram program running, and I'm going to show you an example of that in context. Okay, this is just a React app. I'm going to pick a condition, 1,000 to 1,000. And there's our diagram. So it looked through the million patients, found the conditions, and then tracked the patient journeys and aggregated them for all of the patients having those. And then it creates this nice diagram. Any questions before we jump into the code for this thing?
Maybe a quick question. We've been talking about using user procedures for a while, and sometimes, you know, there might be a functionality that you can use in Cypher, but at the same time, you can basically build it yourself if you want using user procedures. I saw that you suggested that generally we prefer to use Cypher.
Right.
But other than, you know, those, for example, periodic iterate or periodic commit or those functionalities, is there any other use case where you might prefer APOC over Cypher, where both support, you know, a particular functionality?
I would say, this is Ravi here, for traversal. For example, Cypher is path distinct traversal. So it needs to make sure all paths are traversed, and it needs to keep them in memory to check that aspect. But APOC traversal, you can say node distinct. So in that case, once I reached a node in a traversal, it will, second time when if I reach that node, it will not go through that again. But in Cypher, if I came to that node via a different path, I will continue again because it's a different path. So that's where actually the Cypher becomes more memory intensive. So path traversals is the best scenario where you want to use APOC. Another thing is the functions. There are some utility functions, map and collect and distinct, some of those things. They are done a bit more efficiently in APOC. Then other thing comes into picture is in APOC, they have added quite a bit of interactivity. JDBC, Elasticsearch, MongoDB, all those connection points they started adding in APOC. So those things, they're again third-party libraries, what Matt mentioned.
Okay. And the way that if I use some sort of, you know, APOC call in my Cypher, I suppose that basically I'm not sure about the order of the commands. So Cypher as a whole, I can use profile or explain to see the sequence of work.
Yes.
If I use an APOC call,
it will break. It doesn't give you any kind of profiling information.
Yeah.
That is true. So that's one limitation. The store procedure, because it does not know, it does not have an execution path for it. It cannot tell you anything. So it will ignore that aspect of it. It will give you 0 dB hits for it.
Is there any plan to maybe support that?
That's the problem actually. It's your procedure should provide, there's no extension as of now. We have to find out, because if there is a way the procedure can give out what kind of dB hits it is doing, those things, it may be able to show that, but I don't think there is any extension or any kind of capability built into Cypher itself.
Okay.
That is there. I can find out Cypher team if they are planning to do anything like that.
Okay, cool. Thanks.
Good question. Did you explore looking at the architecture that you had way back, the slide way back when, and taking a look at that as part of the source? And I'm not criticizing what you had, but oftentimes I find people putting relational models into graphs and getting a Cartesian coordinate problem. And then that would make sense for Java to then get some kind of use of maps or linked lists or something like this, to where it could create efficiencies against a Cartesian problem. So I don't know if you explored different architectural approaches, because graph theory points towards sometimes some very seemingly complex looking graphs that actually, because it's a big O of like 1 traverse, it can be very fast. A lot of times I look at architectural solutions. I love this, by the way. This is super helpful because I can see a million alternatives for using procedures. But my question is, as you went through this, because this is near and dear to my heart, because the whole idea of journeys is a very big part of the human experience that I work in, and it becomes a mammoth problem. But as you begin to model it, and you look at, even math like factor analysis is incredibly complex to come up with a fairly simple way of doing things. Point is, there's a question in the back of my mind if you've looked into that.
The problem here is not that Cypher cannot do it, but amount of time Cypher has to do, because the Cypher being path distinct becomes a big problem. So what Matt mentioned here is the next relationship. Cypher cannot stop. It has to expand, keep expanding, because it doesn't stop and check at every expansion.
I don't know where that's coming from.
Yeah. So another thing is, for example, I don't need to have this kind of complex.
Sorry about that.
If I have a simple binary tree.
Oh, I can mute that.
Yeah, no, I'm sorry. My phone started ringing. I apologize.
No problem.
No worries.
So if I have a simple binary tree, the moment from top, let us say it is 5 levels deep, Cypher can do easily, no problem. It can traverse through any aspect of it. The moment it starts going 10 and above, the Cypher starts having memory problems, because number of paths is 2 to the power of n minus 1. The moment I have a 1000 level deep tree, Cypher cannot keep that in memory. Its traversal is fast, but it has to keep that in memory. That is where it starts having the problems.
Yeah,
that's what
I certainly heard that when you talked about the distinct, because that is what you do in a Cartesian problem.
Yes.
Is you try to get distinctness, right? That is what n log n kind of algorithms try to do, right? So my question was, just use that example. If the binary tree makes perfect sense to you and me, but the actual relationship between nodes is much more complex, but thereby the path, which may be 1,000 levels deep, but you don't have the recursion problem, you go straight to the 1,000. And big O of 1,000 is nothing in terms of time.
Yes,
but as designing the architecture, it would be, what I'm looking at on the screen now, would be monumentally more complex. And as you look at relationships in graphs between experiences, the experience is divided, and this is what I mentioned factor analysis, if you're familiar with that. that mathematics, is that you can sometimes have 1,000 dimensions. And that actually simplifies things, because out of that 1,000 dimensions, you get 6 factors. And once you have that, you have an ontology that then powers, and no longer is a binary tree, a worry, and a recursive problem space. So it's something I believe very strongly is an aspect of graphs that we don't use. A lot of the Neo4j examples do not play on the ontology theme, because that is the higher level of abstraction. Like the animal kingdom, etc. So I just wonder if you've played with this in this problem.
That's where the problem comes into picture. When you go into too abstract, that becomes for business people, especially businesses, it becomes too abstract and it doesn't make sense. Okay, what are you trying to do with the model? I'm not able to follow. That's what it will end up. So the balance comes between, does it make sense to people? Can they manage it? Can they maintain it? That becomes the problem.
Yeah, no, and that's what I do when I work with business people, because I love the whiteboard friendly part of a graph, because you really get business people very excited. But the ontology conversation, which is the classic one, is the animal kingdom. That is something a business person can also put their arms around, right? And being able to take a problem like I'm looking at, providers, address, patients, etc. The actual relationships in there are way, way, way more complex.
That's true.
Right? But at the ontological level, it still is animal, reptile, fish, bird, that kind of stuff, right? So that's the whiteboard friendly part. But when it gets to our job, whether we fix it by trying to make sure that we can find some fix around the fact that Cypher is doing what you're talking about, I fear we're going to end up, and it's just going to be a matter of time where even Java can't save our asses, excuse the French.
Yeah,
right?
that's always the case actually, because how much of data are you trying to put?
Exactly.
It's always actually, if you look at it here, the next relationship is making our processing much more streamlined. The next relationship is not coming from data. So we are loading the data. So patient has an encounter is type of allergy. Patient had an encounter drug. So each of the encounters has a timestamp. So once the data is loaded, to make my processing simpler, we created a next relationship. Next is an inferred relation. So it's like a bit more higher. It's like abstract concept. Over the timeline, this is how these are connected. So that's an abstract concept. That's not coming. Nobody's telling us, oh, this is coming from this thing. They just gave an encounter happened at this time. So that next relationship itself is a sort of abstract relationship we created to make traversals faster.
Right. And that's my question, really. If you nail down the architecture, if you pull next apart in its own graph, right, the next becomes a subgraph.
Yes,
you could potentially exponentially pare down the amount of things you do without having to code around it. You'd still have the graph model do it for you.
That's why actually, because whatever Matt showed, I start from a condition. Condition is distinct node. From condition, it is connected to all encounters. From once I got the encounters, I'm traversing next. So my data set in a 200 million nodes data set, my whole thing is reduced to less than 100,000. So that's why the speed is coming in the Java code, because I am hand coding my traversal. That's where the speed is coming.
Yes, and the distinct for me is actually created a path, and that's why I wondered if you guys, as you were using that, discovered a path that would expose an architecture that wasn't in your original model.
That's
that could have, in fact, done.
The next was the relationship.
Right. Sorry to take so much time.
No, because this is why and how we want to use a store procedure, and what advantage does it give. This is what is required. Yeah.
Well, that was super clear, and I'm super excited by that, because there's lots of bad architectures out there that the store procedure can save them for now. Right?
No.
My question to an intelligent group like this was, is there a way to save that for the rainy day, right? To be able to leverage a better architectural model to then use the store procedure to make this kind of stuff instantaneous. I did a project at Microsoft where we had 2 billion nodes, and I attached an ontology onto it, and it greatly simplified a lot of the work that did surprise me, but it still took hours to run. So
yeah, so that's where actually what you mentioned is perfectly valid. That's why we keep saying Cypher. If you think that Cypher is not able to do any of your work in the graph, then most likely your model is incorrect. You have to look at your model.
Thanks.
That's. So Matt.
Yeah, let's, should we look at some code?
Yeah, let's go through the code.
Let's look at some code.
All right.
Yeah, you might have to zoom in too, because like.
Oh yeah, I'm gonna put it in the.
Cool. Yeah, you got it. You got it.
Yeah. Okay, so here is this is my procedure. You'll see here at the top, I'm using the context annotation to get a handle to the database and also to the log. And then my method, I annotate it with this procedure. This gives the name of it and the parameters. So one thing interesting here, there's only one integer type in Cypher, and that corresponds with Java long. So my inclination would be to use an int type for age, but there's only the long is what to use. Okay, so at the start, I get a list of lists that we will put our journeys, patient journeys into. I use the graph database service to open a transaction. Find encounters where the condition occurs. I do that in a different method. Actually, I'll come back to this because it's a little bit more complicated. So once I have the start points, and notice these are just longs, which is the internal ID of the nodes in Neo4j. So for each of them, I set up a list of strings to hold the path in. I retrieve that node, that's the start event ID, by just saying db.getNode by ID. Then I can access its date property, which happens to be a zoned date time, which is one of the Java 8 time new classes. We figure out when the start date occurred, convert it to the epochal millisecond format. So we're at the start encounter. So journey type, for the example, we're collecting procedures. So a procedure could have occurred in the same encounter in which the condition was diagnosed. So we collect it if it's available. Then we set up an infinite loop. And we look at, this is where we traverse along the next encounters. So we use a variable to say if we should keep going or not. One thing I didn't mention is that it has the capability to show the Sankey diagrams in reverse, which means instead of showing events after a condition was diagnosed, it'll show the events before. Regardless, we just traverse the next path. We either, if we're moving forward, we use the outgoing next relationship. If we're moving backward, we use the incoming next relationship. If there were no more relationships, we can just break out of the forever loop. One attribute is some encounters mark the end of a particular encounter. We want to skip over those. So we do that. Now, N is pointing to the next encounter at this point. So now we get the date of that encounter, and we figure out if it was within the date range of the start date. If so, we keep going. If not, we break. So let's take a look at what happens in this collect from encounter method. So here I'm saying this particular node, journey type is the sorts of events that we're collecting. and that this is the path so far. So this just delegates it to the appropriate relationship to look for. Now we're on our encounter node. We get relationships. In this case, what was passed in was has procedure. So that is the other side of the encounter node, has the procedure. We get the description and code. We encode those into a string. That this is what our the diagram uses. And then we add that string representation to our path. So once we've reached the end, we've either broken out of the path because we're outside of the date range, or there are simply no more next relationships. Now we can commit the transaction, and now we can summarize the paths. And so what this just does is we have a list of paths, or a list of strings. This function just converts that into a map where the key is the list of strings or the path, and the value is just the number of times that occurs. And then that's what gets returned from the procedure. So going back to the start events, so what's going to happen here is we're looking for encounters where this condition was diagnosed for patients who fit the demographic filtering criteria. So the way I did this was to create what's called a filter compare. It's sort of a structure. It's just a simple interface that has a compare, lets you compare something with a reference thing. And there's an implementation that for doing that for equals. I have one for doing that to test that a number is between a particular range. And finally, for the age filter, to make sure that the age is in an expected range based on the years. So I use the, for gender, I can just use the equality filter. It's going to match statically with the filter value. Same thing for race. For age, it needs to be a little bit different because that's going to vary depending on the encounter, and the patient's birth date. So we need to apply that one dynamically. First of all, we find db.find node here. We find the condition that we're looking for based on its code. There should just be one node. We get all of the relationships incoming that have condition. This will point to an encounter. We iterate over those, get the other node, which is the encounter node. Then we get the properties of the encounter. We make sure that it's not an end encounter, and we get the date in which that occurred. Now we can use that now we can add our age filter because we know how old the patient would be at this particular time, so we can do the filter. Now that we have our filter structure to compare the patient against, we get the patient node by expanding the relationship has encounter. So patient has encounter, we get the incoming node, which will be a patient node. Then we get the patient's properties, and then we look through our filters and make sure that the property matches. If it doesn't, we say matches equals false, break out of our loop. Otherwise, it matches, it will be true, and then it goes through all the comparisons. Finally, we remove the dynamic filter so it can get added for the next one. And then if it matches, we add it to our collection of start events. And that's it. Any questions about these? Oh, I should show you the POM file. What's wrong? And back to presentation mode. So this is our dependencies. We need Neo4j. The whole jar is a provided dependency. We also have the procedure compiler. I'm using the test harness, the Java driver. I have an import on a specific version of Jackson. I can't remember why, but that brings up an important point, which is that you can end up with sort of like jar hell kind of issues if there are multiple versions of a library in your jar versus what's in Neo. So using the Maven Shade plugin, in this particular case, I'm excluding that dependency because I can get it from elsewhere. You won't always have to do that, but if you start to see like exceptions about like can't find this particular class or abstract method errors, things like that, the sort of the markers that show you that you have like multiple versions of the same library going on, you can do something like this. Any questions?
I've got a question. You talked about debugging on your slides.
Yeah.
And you said there's step-by-step debugging available. Is that when you use tests in Java?
Yeah, there's a couple ways you can do it. Let me just drop out of this. I don't really know how to get around very well in presentation mode, but so there's a couple different ways. I'll show you my my tests. All right, it's under. So in like a before class, this is a JUnit 4 test. So this is used to construct an in-memory instance of Neo4j, and then I just tell it my procedures. Journey proc is the one we were looking at. There are other ones there too. The other neat thing with the test fixture is you can, the test harness is you can provide a fixture. So it'll just run this big statement to put some data in the database when you start testing. So with this, I mean, you can just run it and set a breakpoint on the procedure, and it will hit. The other thing you can do is you can actually start up a Neo4j server with remote debugging. And then if you start it up that way, when you call your procedure and set a breakpoint within your procedure, it will hit that.
You need to connect it from here. You have that set up runtime.
I do, yeah. Yeah, let me
execution.
I think I have it here.
Yes. That's all, not that one. Can you go to Neo4j debug? Actually, can you go to the
oh, right. Okay, yes.
Configuration, edit configurations.
Yeah.
So if you go to edit configurations, remote. So Neo4j debug. So there is a documentation available in Neo4j document site where the JV and debug conditions, you need to enable the port 5005 port. So once you enable that, so it will be listening for the debugging requests. So from here, when you IntelliJ, when you put this and say run, then the debugger will attach to that running instance. Then when whatever breakpoints you put in your Java code, when you are executing the database, a store procedure, it will hit the breakpoint and you can debug.
Okay, cool. Thank you.
Sure. Yeah, and I can show you in the Neo4j conf. You can add a line like this. I have it commented out, but it this
That's the one, JVM.
Yeah. Other questions?
Going once. Going twice. Nobody has any questions? Maybe you were just that thorough.
Maybe so.
I mean,
What did you guys say? I couldn't hear it. I'm sorry.
I said he did a really good job. It's outside of trying to pick apart all the code and try to understand it line by line, which I think that we probably don't have time for. That's a joke. No, it's just nicely put together. And the presentation is clear. It really opens up. It really opens up the power because you still have the graph underneath, and you're just enabling, you know, sort of a brain on top of that graph. So I think that's pretty cool.
No, this isn't running. Never mind. I thought I'd be able to show you the remote debugger in action.
Yeah.
But I think I need to start some things.
Oh, okay.
I need to start my application, basically.
No, actually, you can just call the procedure directly.
Oh, from Cypher? Yeah.
From browser.
Yeah, the problem is it has so many parameters. Now, what I think should happen is, wait, what's this? What the heck's going on?
Or did he hit the breakpoint? Yeah. This one, there's a lot of documentation about how to debug.
Yeah.
So even if you have your Neo4j server code community, this thing, you can do the same thing. Debug.
Right. So for the regular, for the unit tests, in my procedure, I can set a breakpoint. And then
debug. Not run, debug.
Oh yeah, nah, jeez. I'm much better at this when people aren't watching, I promise. All right.
They call it the demo daemon.
Mm-hmm.
So you're not the only one. There's literally a term for it.
So it's spinning up, and now it's hit my procedure breakpoint. So now I can just step through it and just like I would any Java program. Other questions?
You guys can ask about other things too if you have anything else that's on your minds.
I'm gonna have to rewatch this. This is my first time like doing a deep dive on user procedures, so I'm still wrapping my head around everything.
Sure. Yeah, there's on the slides, the last slide has a link to some blogs. It's this guy Max DeMarzi at our company who's does a lot of demos of these. He has stored procedure stuff. The cool thing about his is that there's GitHubs too, where you can check out his code. So that would be a good way to learn more.
Yeah, Max is great.
Yeah, I would just be careful with the one, which is the last one, because it uses the internal kernel. And it's good to know, but the actual use cases for it are probably pretty limited in real life.
Thanks for doing this, guys.
Thank you.
Sure.
This is
Yeah,
very
that's
good.
really useful.
Cool.
Did you guys find this valuable?
Absolutely. Absolutely.
Okay, cool. I figured like since you guys are like very often like at the front lines of like helping people and stuff like that too, I was thinking about how much like hopefully that a lot of this content can like be valuable for you if you're like applying it when you're, you know, helping other people and stuff too.
Well, I wonder if any of these, like in the future, we could even do like a step-by-step like process of making just a simple one, because I think sometimes as soon as we get into that, if you're not familiar with Java, which I'm not, it seems a little daunting. So having people kind of step through together could be a fun exercise as well.
Yeah.
Yeah.
Mm-hmm.
That's something that makes sense. I mean, you know,
Yeah.
Matt, Ravi, we can talk about this offline too, but I'm thinking about doing some more like kind of like bonusy type of sessions for like the Ninja stuff. So maybe that could be something for that if you guys would be interested in it, so we can.
Sure. Yeah. Maybe.
Do you guys play with Python at all? With
Yes.
this kind of idea where you're, because I've been looking at a lot of utilizations for Python for what I want to do, and a lot of it does remind me of this presentation that you've just done, Matt, but way less intense in terms of the amount of code, but it did get in inside each Python call, it used a lot of procedures, and I could see where you could build your own procedures as you're building a data science project out, where those would be kind of the, if APOC doesn't have it or GDS doesn't have it, I could certainly see where that could integrate with Python. So that might be interesting.
Actually, when you mention it, we have the ingestion for this was a Python script we wrote. We could take CSV or JSON. We could share that utility with you guys, because that makes life a lot more easier. We have a Python script, and you will write your Cypher and file location in YAML configuration and let it run.
If you know, of course, Neo has in some of their training, they have sort of a data science thing, and I don't know if you're familiar with that, but I took the Cypher code out of some of the stuff in there one time and put it into the browser, and it froze my machine. And yet, from within the notebook, boom! I mean, it was like screaming, and I just found that really fascinating, because it does seem that Neo, I think you've hit it on the nail, of where you're, you know, the challenge of a recursive model is it can get big. Yeah. And actually, I think the example you use in the citations network has about 35,000 nodes or something, and you know, that n squared of that is pretty big, right?
Yeah, because we have run some similarity algorithms on patients on this, because regular graph algorithms are monopartite. You cannot compare only two nodes at a time. So we have written using this store proc. We export the patient journey as a one single document, and we use the Met2Vec Python data science library to find which patients are similar in terms of their journey.
Well, you touched upon a very interesting thing I go through a lot of it is the bipartite, unipartite, that sort of idea. And referring to our earlier conversation, I think bipartite graph application can greatly simplify things. Have you guys played with that?
Yes, actually in GDS, that is a little bit of coming into picture. But even then, this for patient journey itself, we didn't use bipartite. That itself was limiting, because from starting point to end point, there are multiple things. The whole journey as a single document, we need to compare this thing. So that's where actually the Met2Vec is one of the Word2Vec offshoots. So it creates a sort of similarity algorithm, cosine similarity. It makes it a document with more matrix and does a cosine similarity to give similarity.
Yeah.
So those things we have used.
Yeah, I can see that. But being able to eliminate, because that's part of the problem, is eliminate the noise.
Yeah.
When it isn't noise all the time, right? And that's what creating a unipartite or basically using a bipartite strategy.
That's true. So for one of the customers, actually, not from the patient journey aspect, for the providers. So the provider dealt with patients. So how providers treating patients. So based upon that, how providers are similar and who is the most influential.
Yeah.
That one we have used this graph algorithms, bipartite, monopartite aspects of it. So the similarity algorithms. So those there we have used the similarity algorithms to see who is the most influential provider, based upon how they are prescribing a drug, how two providers are similar. They provide the prescription patterns or diagnosis patterns.
Mm-hmm. Yeah. Wow, that's cool.
Cool.
Thank you.
Thank you guys for joining us today. And Matt and Ravi, thank you guys so much for taking the time. This is awesome.
Pleasure.
Thanks a lot, guys.
Thank you, guys.
Yeah, this is great. All right, cool. So thank you, everyone. And hopefully we'll see you soon, maybe this week, if you guys are coming to any other sessions.
Fantastic.
Awesome.
Thank you.
Bye.
Take care. Bye.
Bye.